Hi, my name's Robert. I'm an architect for Microsoft, so I am not going to try to sell you anything today. Um, what we're going to talk about real quick is we've done a lot of migration. So 90% of how we run Microsoft is actually in the cloud. And of that, about only 26% is IaaS, so there's been a huge focus on PaaS and serverless as we've made that transition. Now, part of that 10% that's still left is some of these rock hard applications, and one of them go through is MS Sales, and this is our key revenue system at Microsoft. So think about this as all $90 billion of revenue go through this system, and it's basically attributed, and so one line comes out and like 200 lines come, one line goes in and like 200 lines or 400 lines come out. So it's really split by geography, business segment, those kind of things. There is a meta point I really want to try to get across, which is as you're doing your cloud migration, right, you're lifting your line of business apps. In this particular case, it's a financial app. It's a great opportunity to start thinking about modernization, right? That modernization is really about having a vision of where you want to go. And sometimes engineers, we as engineers have to push the boundaries. Because I don't know about your finance. Is anybody in here from a finance or work on finance applications? Okay. Trying to explain something like eventual consistency to an accountant is really tough, right? And you tell them, hey, your numbers are going to change every 30 minutes or every 10 minutes. They kind of wig out and they want to go hide and cry in a room and say, no, you're not doing that. So I just wanted to give you a little scale. And the first scale is just a scale of this particular application. So we get about 1,500 sources. We import them into a traditional data warehousing pattern. We do a lot of transformations. There's about 35 terabytes of data total. So that's not the end product. But if you think about all the different databases that we have, about $2.6 million transactions come in. But the problem with this system is it produces numbers every 24 hours for our accountants. And so there's a big bunch of business process that's been added to this. And what this does is this really creates an impingement point where we can do better. And so the vision about this is says, okay, we're going to move this to the cloud. How do we do so in a more modern fashion? So these 3.8 million rules of dynamic SQL, this is actually dynamic SQL sitting in tables being run in the database as a transaction. So trying to figure out what went wrong, if there was a problem, you basically have to go through those lines of code. So MSLs, I'm going to back up one, sorry about that. So this MSL was a shipping feature for MSLs, for SQL Server. So if you think about it, when we first started, SQL Server would not release to the product unless they basically certified against MSLs. That's how important the system it was. And that's how the stress on SQL was. And you can see that over time, we've added new features to try to keep increasing process. It's really about compute power. So what's happened to Microsoft that's made this change? Our business model has changed. We used to sell you a copy of Windows or copy of Office or whatever it was, and 3 to 6 years later, you'd come back for an upgrade, and we'd sell you another copy, right? Now with Office 365, that's a line every month, a revenue transaction every month. With Azure, it's pay for usage. Our first Skype transaction came in at 6 cents. So if you think about a $90 billion company, where we started out at basically a transaction volume of about $400 per line of transaction coming in, and we're down into the cents. SQL just couldn't handle it, to be honest. Now, we tried everything. So basically implementing partitioning, parallel queries. Then we started splitting months, and we said, okay, let's buy 2 gigantic beasts, and we'll go half the months on this server, half the months on that server, and then we'll put them all together. This is basically what it looked like. So pulling it all in, and these servers are actually 272 core, 2 terabyte machines with extreme I/O hooked in behind it, right? So these are not small servers. And then We have 30,000 users across Microsoft looking at these reports, and so we basically would just spit out a big beer can of data across 21 servers for people to actually query and to pull data. So we need to move this to the cloud. We had a couple of different ways to do that. The first is I could take a little bit of a processing, a little bit of ingestion, processing, and distribution and try to move it. The problem is that from an end user perspective and that business process that we use to 24 hours data, they wouldn't get to change their business process. And so what we decided to do is take a small vertical, horizontal slice and take sections of that and move that to the cloud. And that's what this represents. And I'll go through this a little bit more. But instead, so we have things called channel. Channel for us is Best Buy, gray box partners, those kind of things. If you think about our inventory pipeline, that's around, hey, channel partner sold Surface. I need to restock that. So supply chaining that hooks into this. So let's look at this a little bit differently. So the vision, to be really honest, the vision is really, and Amy Hood's our CFO, is really around, I want a counter in our office, a light, that just does, has anybody watched Lost, or maybe that's too old, where the counter just clicked every time the dollar came through. And so now we want retail and channel partners to actually, as the cash register rings, we want them to write to an event hub, and then take that transaction and go ahead and spit it all the way out, like a single entity. So to do this, we had to retrain our whole engineering staff, and we said, what technology do we want to use? And we chose Spark for this. So we're running Spark on top of HDI clusters. And the general gist is, as information comes into Event Hub, we stream them out and then produce data to the user. So what's the benefit? Well, for IT, it is, I can scale up and down, right? I have distributed processing. For the business, they can see data in minutes instead of hours and days. We can go a little bit deeper, and I'll be available after this. Sorry, this is kind of... So this is basically the money slide. Right now, we run on 5 nodes in HDI, and it takes us about 10 minutes to process that small vertical process, things that used to be 24 hours. We have a restatement event, and a restatement event from a financial terms is I got to basically redo my calculations for 21 years, 10 years behind, 10 years forward in the current year. So it just increases the data. I can bump up my cluster size to 15 nodes. I can process in 42 minutes. Then we did a stress test, and we said, we know Microsoft is not going to, stay stagnant. We're going to grow. So we bopped it up, and we bumped it up to 3 billion rows. And 3 billion rows, my processing time only increased 10 minutes. And most of that actually is on the backside. So from a standpoint of being able to scale as Microsoft grows, so the things that we really wanted to do were, we wanted to get faster data, latent data. We wanted to be able to componentize the MSLs, because it was built 20 years ago. And so all the code was kind of spaghetti-ish. It's hard to decouple. And then we wanted to be able to scale and meet our needs. We don't want to have to invest engineering into splitting factories or moving the distribution into different servers. So just going to go quick through. So from our engineering team, here's the things that you need to think about if you're moving from basically relational data to a big data processing engine. Number one is, they're born from a pinned-only store. Now, I know there's update features coming, et cetera, and in some products they have update features, but they're really born from a pinned-only, and you have to deal with that. Streaming in micro batches. So we like Spark because I can mimic basically streaming with small windows. The default window is 3 seconds, but I can do big batches of data, or I can do small batches of data, and I can tune it. And I use the same code to do either one. Patching, lesson learned, Windows patching, Windows update is a godsend. when you're dealing in the open source world, right? That product is changing all the time, and you have to stay on top of patching. And if you haven't seen, there's a breakout session that I did yesterday really around security, and this is where this comes out. Back-end problem. We haven't solved the back-end. So we still are actually loading SQL databases on the back-end for high concurrency reporting. It doesn't matter what you're doing, Hive, Spark, or some other query engine, concurrency becomes a problem. And if you're at 30,000 users and you're trying to get high interactive queries, the best bet is still relational in my mind. JDBC driver issues, we just uncovered. If you're trying to write from Spark to SQL, we actually had to customize the JDBC driver. It's slow. Polybase, we're actually loading into ADW as well as SQL databases. Polybase on a data load, extremely fast, right? Now you pay a performance penalty on the small queries because you have a distributed MPP database sitting facing your users. And then from a business aspect, and I know these are developers, but one of the things that we've had to do is we actually tie performance to the speed of data. So instead of saying, I need $5 million a year or $2 million a year, whatever the cost is for 24 hours, I get to have conversations with our business around how fast do you want it? And it ends up going like this. How much money do you have? Right? That's really what it is. Because if you have a lot of money, I can make a lot of nodes. And then we start walking back from that to try to find out what the right frequency is. See what else. Outcomes. We've already said this, right? So basically, we've improved our processing time throughout the system. We've gone from 24 hours to now they can see channel data and inventory data in less than an hour. And our goal is 15 minutes. Scalability. I can go as big as they want to go. So if Microsoft wants to start charging microtransactions, microcents, we can do that too. And then increased agility. So again, this older system was 21 years old. If you think about it, after 21 years, an application, a line of business application, is going to have some rot, some code rot, right? Some extraneous code that's just not there. So this is an opportunity to actually componentize the system so that we can upgrade and be more agile. So I don't really have a whole lot more. I would love to take the last maybe 5 minutes to see if there was any questions. I'm much better in a conversational mode. Sorry. Any questions? Sure. The future or the old one? Yep. So this is kind of like flying an airplane, changing the engine while you're flying an airplane is kind of the thing I say. Wall Street really hates it if you don't tell them how much money you're making, right? It makes the stock do bad things. So we have to do an incremental approach. So we still have some on-prem, non-Azure sources. Our SAP system is sitting in IaaS, but it's a CorpNet source. Our channel partner, so the way you read this is the light blue things are things that we're still working on. The dark blue things are things that we've kind of completed, right? Part of this was really around getting our engineering teams comfortable in new technologies, to be honest. If you're sitting and you have an application that's been there 20 years, I'm pretty sure your engineering team, and if it's based on SQL, they know SQL. They probably don't know Scala. And they understand how a SQL database works. They probably don't understand how a append-only score works. Those type of things. Was there anything in particular you wanted to ask about here?
I was curious about what types of storage mechanisms you were using on Azure Storage.
Sorry?
The types of storage mechanisms you were using on Azure
Sure.
Storage.
So he was asking about the types of storage that we were using. So we started out with Blob right now, and then we are moving to ADLS for storage. So basically Blob, because when we started the project, that's really what ADI or HDI HD Insights, the product name, actually connected to Blob. Now it connects to ADLS as well. So it's a future plan. So we'll upgrade, and the reason is really performance-based. Performance and POSIX controls. So ADLS has nice POSIX controls.
How do you plan to migrate all your data from SQL to this?
So his question was, are we planning to migrate all our data from SQL to this? Yes.
How do you plan to do this?
So
What's your plan?
what's the plan? So the first, so it's a trick, kind of a trick question. All of our data will actually end up becoming in relational. What we've changed is the compute, the processing, the transformation, and the ETL. We've transferred that to Spark. So our data will end up in basically ADLS in the future with customer-facing SQL databases, SQL data warehouse, Azure analysis services. Excuse me?
Same structure.
No, different structure. So opportunity. Opportunity was, hey, instead of producing one big beer can of data, we can shard data and put them in geographic locations close to the user. So Microsoft being a global company, we have users all over the world, right? So we want to place the data as close to the user as possible to eliminate that query response rate. And not only that, small data structures perform much better than big data structures.
Split your data based on geographic locations of the office.
So what we'll do is, so if we have people and we're in Europe, we will have replicas, SQL database replicas sitting in Europe. All data? No, not necessarily all data. So the data that is used. So we have a lot of telemetry on how people are querying the data. Again, something I would build in, which basically says, hey, these queries are the most used. So what we're end up doing is we're going to put APIs on the top of this, and we're going to basically make intelligent routing decisions. So you'll hit the API, and if it's a long-running query, we may run you to ADW instance, right? Because now I can have distributed processing or a distributed query. If it's a short-running query, this actually, the SQLDB actually outperforms ADW. And then if it's maybe a data scientist, maybe I write them back down to the Parquet file that's sitting here if they want to do ad hoc analysis.
Is this API going to be available to the public?
Is the API going to be available in the public? Not probably the one we write. There is some products that may have that in the future. Any other questions? Clear as mud? Yeah? No? Okay. Sorry, I was just trying to, 20 minutes is a short amount of time to get through this stuff. So there is some more material if you are interested. IT Showcase. So IT Showcase is actually a great place to go. Get white papers. You can see this. You can see things we've done with tax, things that we've done with forecasting, predictive models, those type of things. So it's a pretty good way to go. Thank you.